Hey, what's up? What's up? It is Wednesday, October 18th. You see what that is right there? Let's just go ahead and move it right along. Okay, cool. So there's a few things that we just need to address, okay? One is this idea, is people keep just throwing papers or things, and Mr. Farr's like, no. Look, I'm going to assume that what you were trying to do was throw it into the trash can. So if you miss, hey, if you miss, then we're just gonna go ahead and start that process of an ODR. So just understand that. We're gonna start first because Mr. Farr's like, no, just throw it away in the trash can. It is your option to shoot it, but if you miss, again, we're just starting that ODR because I'm like, no, we need the trash to go inside of the trash can. Okay, cool. Then we're gonna move over to this thing over there about the eating in the classroom. Same thing, right? My expectation is that, hey, if you need to eat before class, then you can let out outside like 30 seconds or so, and then you can finish your food and then come in. If you really need to eat during class, let me know, and then we can take care of that. The problem is that people aren't responsible, and they can't just throw food away in the trash can. And again, it's just like the papers. Like, you can't, like, for whatever reason, students are like, no, I just got to throw it on the ground. And I'm like, no, that's not cool. So it's very disrespectful in my classroom, and it's just disrespectful in general, is to just throw trash on the ground. No, throw it into the trash can, okay? That's the number one reason why I'm like, no food in the classroom, because people just can't be respectful with their wrappers and their things, okay? All right, let's go over here to this, right? About the phones. So I'm just letting you know, like, I've seen a few people, like, now that we've been in school for a while, people are starting to be chill. So a few people are starting to use their phone for inappropriate reasons. So again, appropriate usages would be like turning your homework. Like the other day, we used it for a compass. You could use it for like a timer if we're running a lab or something. So those might be appropriate usages of the phone in the classroom. So make sure that is what you are using it for. If you have inappropriate usage of the phone, then Mr. Farr is just going to be like, okay, the phone's going to have to go to the office. It is what it is. And then the last thing down there is hoodie season. It is my favorite season, but there are no hoods on in the classroom. So just as you enter, just make sure you take them off. That also goes for no sunglasses, okay? So just make sure when you come in, hey, just take your hood off. It's totally cool. And then when you leave out, you can put your hood back on. Not a big deal at all, okay? Let's just move forward with that. I just wanted to make sure to clarify those things so that people can know in the classroom. I just don't want them to be any fair warning, and I don't want to get lax. Just know these are the expectations for Mr. Farr's classroom, okay? All right, cool. Let me ask a question here, and the hard part is we're not face-to-face, but I would say like this. You can go back to the last video lesson. If anything look crazy, go back to the last video lesson and you can watch me work through all of these problems. So hopefully all of this looks good for you. Let me click at the bottom there and just talk about this northeast for a second. Since we had northeast, so this right here is east and this part is north. Then when we're heading in this direction, we're heading in a northeasterly direction. And I do also want to say the distance from the start to the final position, that is what we call displacement. Now, if you look at the distance traveled, I move myself out the way. Distance travel, totally different thing. So we went down, up, and then back this way. So we went all kinds of different ways. So we went like, again, east, north, and then west. That's how we got to here. So again, that's going to be like the distance traveled is 640 meters, but the distance from there to here, so from start to finish, is going to be a lot less than 640 meters. And that's how you can tell the difference between displacement, how far the object is from its starting position, right? Or distance traveled, which is the total distance that the object traveled in as a whole, okay? All right, cool. Let's move to the next one. And I don't think we need that. I think we need this. So I'm going to move myself about the way. Let's go ahead and watch this video right here. Okay, let's go ahead and watch this thing right here.
In most science experiments, you will have three variables: the independent variable, dependent variable, and control variable. An independent variable, also called the manipulated variable, has the ability to stand alone. It is the variable you are changing or manipulating. In simple terms, you change the independent variable. You will find it on the x-axis. The dependent variable, also called the responding variable, depends on the independent variable. It is the variable you are measuring. In simple terms, the dependent variable is what you measure. You will find it on the y-axis. Control variables are variables that need to remain constant for accurate results. Let's take a look at a simple example. I would like to know if higher air pressure in my car tires will increase my gas mileage. I will test my car at 20 psi and then at 35 psi and see if the miles per gallon changes. The different air pressure will be the independent variable. It is what I'm changing. Measuring the miles per gallon is the dependent variable. It's what I'm measuring. And driving the same car each time would be one control variable.
Just one.
This will help keep the results constant. So in summary, the independent variable is what is changed, the dependent variable is what you measure, and control variables are variables that don't change that help keep the results accurate. Remember, kindness multiplies.
Oh, look at that doggy!
Thanks for watching.
All right.
In most science
Okay, so let's just take this. You need to take this as a note. Mr. Farr is going to talk about it, but you just take it down as a note. So pause it whenever you need to. So the independent variable, again, is the thing that you are going to change. And in that case with that car, he changed the PSI in the tire. So the pressure that was in the tire. Now, this right here, okay? Just so you, and then it says it's graphed on the x-axis. So the independent variable, the one going up and down is your y, and the one going left to right is your x. So here, we'll look at this. And he says that's going to be the independent variable, the manipulated variable, the thing you're going to change. So inside of science, just so you know, we always are mostly going to be graphing in this top right coordinate because it is positive, positive, and usually when we get data, it is positive, right? So in this case, it was PSI, so he had one here for 20, right? So we'll put that there, and then another one here for 35. So, and again, we'll label that as PSI. That's what he said, right? So that's totally cool. Then he's going to measure the gas mileage, right? And so that's going to end up being on the y-axis. So we'll talk about that on the next slide. But as you can see, the independent variable, which is the PSI, which is the thing that he's going to change, the pressure inside of the tires, that's going to go on your x-axis, okay? Cool. Then we're going to move here. So I'm going to move myself out the way. The dependent variable is responding variable, or the variable that you measure. I also would say that this one is what I would call it is your data variable, okay? So I'm going to call it your data variable as well. And that's because it is the one you're going to measure or you're going to write your data down from. And then this one goes on your x-axis and here, on your y-axis. So again, the dependent variable is going to end up going on your y-axis, okay? And again, since it's positive, that's why we're going to be in this top right quadrant, okay? And so this is one of the ones I would have to really think about. So it's gas mileage, right? So like gas mileage, oh, that's what I'm saying. Gas mileage per gallon, right? So how much should we get for 1 gallon? How much should we get for 2? And then you can graph that data. So when we had the PSI, for every 1 gallon of gas, how many miles were we able to go, right? So that's like one of those things that you're going to want to make sure that you're going to be graphing there, okay? So that is going to be what we would call, again, your dependent variable, the thing that you're actually going to be measuring, okay? Then the last one is the control variables. I'll get myself up out the way. Control variables are variables that need to remain constant, okay? So they need to remain constant. And in this example, again, that would be like driving the same car, the gas, like having your gas tank filled up the same amount. That also would be like using the same type of gas. Also, the same route, the same speed, because those things could also change gas consumption. So he mentioned one type of control variable, but again, there's going to be multiple different types of control variables, okay? So hopefully you got all that written down as far as the notes for independent, dependent, and, well, go back. Independent, dependent, and the control variable. Again, have all these notes written down in your journal. Now, we're going to go over this a little bit more in depth right now. Okay, so let's just talk about this. Let's just say if you wanted to compare brands of paper towel to see which one holds the most liquid, which one would be your independent variable? What is the thing that you're going to be able to change? Hopefully you guessed it correctly. It is going to be the brands of paper towels. Hold on, let me get my paper. I got my brands of paper towels, so I got my 3 different types of paper towel, and this is what I can change. So that would be, again, my independent variable. Now, what is my dependent variable? What's the thing I'm going to measure? And I'm trying to measure which one holds the most amount of liquid. So that is what I am going to measure. Okay, so again, that's where my data is going to come from. Well, how much liquid did that paper towel absorb? Now, what are some of my control variables? There's quite a few. One could be the size of the paper towel. So how much paper towel am I actually going to use? Because I don't want to use like this amount of paper towel for this one and then use like this amount of paper towel for another one. That would not be accurate because maybe it's absorbing more because it has more paper towel, right? So we want to have the same amount of paper. Also, you want to use the same amount of water. So you want to spill the same amount of water each time when you're absorbing, right? Another control variable could be what surface do I have it on. If I pour it onto a table and then I'm going to absorb it, then I need to do that for each one. Does that make sense? So those are all some of the what we would call our control variables. So all those different types of things would be control variables in that case. All right. So now let's go to the last thing. So we do have this assignment in here. In this assignment, all that you're doing is you're looking at the situation. Sometimes they're a question, sometimes they're a statement, and then you're going to identify what are the independent, dependent, and the control variables. And I'm going to take a look at that for you, or take a look at that with you. I'm just going to look at the first one. So all right, you know the reds. Go to Canvas, go to Modules, open up this assignment, and then you're going to say File, make a copy, right? Blat out. And then at the very beginning, that's where you're going to put, where it says this copy part right here, you should go ahead and put your first and last name in there. So I'm just going to go ahead and put Mr. Farr. Okay, that's cool. Put that all up in there. And then I'm going to, since I'm making a copy, I'm going to, it says suggested. Where is, oh, I can't find my actual one that I really actually need. So starred, do I have it in starred? I need all the locations. Let me go. So my drive, go next, and then I need to go. Oh, there's Mr. Farr Science. So I'll select that one, and then that way I can make sure all my assignments are in my science folder. Boom, there you go. So then let's take a look at this actual assignment right here. Okay. So now I got my copies. By the way, up here is just the definitions. It's the same ones we wrote down. So, will an egg float higher in water with more salt? Now, the question is, what is the thing that we can control? Okay, like what is the thing? What is the thing? Okay, I shouldn't say control. What is the thing that we're going to change? So the independent variable, that's the first one, IV. What is the thing that we are going to change? And hopefully you thought, yeah, I can, the amount of salt in the water. Is that cool? All right. So that's what I can change. So I'm going to change a different amount of salts, and then what is the thing I'm going to measure? When I change a different amount of salts, I'm going to see if the egg will float higher, right? That's what I'm going to measure. How much higher is the egg actually floating in the water based on the amount of salt that I put in? Now, some things that I want to do to keep control variables would be amount of water. So I'm going to have the same amount of water, right? That's cool. Use the same egg or type of egg. That would be cool. Also, same container for the water. Because if I use a different container, right, if it's bigger, then the water is going to be lower. It's going to be harder to see if it's floating higher or not. Does that make sense? So those would be some of what I would say are some control variables. We could also, if you want to get like really detailed, temp of water. Totally cool. Temperature of water. Now, you're just going to do this for each one of these. Okay, so for each one, you're just going to identify the independent, dependent, and then if you look the control variables, and it says right here, make sure to list as many control variables as possible. So there should be 2 to 4, right? 2 to 4 control variables. If you look, and I think we listed 1, 2, 3, 4, right? So again, you want to make sure that you list out, and you're not writing complete sentences. You're just writing what is the independent, dependent, and then what are the control variables. All right, y'all. Holla at your boy. Peace. Get this done. It is due tomorrow.